Good morning, ladies and gentlemen. Hopefully, all of you are in a good condition. First of all, I would like to say thank you to Atmajana University, ICOR Committee, and all participants. Please introduce. My name is Danang Dwi Prasetyo. I came from Chemical Engineering University of Indonesia as author here. My co-author is my lecturer, Professor Insinyur Sutrasno. In this conference, fifth ICOR 220, I would like to present economic study of offshore marginal oil field development. Content of this conference. First, introduction. Second is methodology. Third, result and discussion. Fourth, conclusion. And finally, reference. Introduction. In Indonesia legislative system, oil and gas is one type of natural resource representing strategic commodity which is important and control livelihood of many people. So the state must have a strategic and dominant role in control. Production sharing contract is form of cooperation between contractor and government of Indonesia as holder. Oil and gas exploration and production activity is profit-oriented business. Main issue for development is high investment fund and profitability. Feasibility study utilized to calculate economic analysis and to minimize the risk. Egg is one of potential marginal oil field with potential reserve around 98 mmboe P50, while Ye is a small gas reservoir located near to Egg. Integration both field by optimizing use of gas Ye as gas injection, gas lift, make-up and fuel for development will provide much benefit and added value. Problem statement. Oil field egg categorized as marginal field only could provide thin net profit, therefore not profitable to develop, but it might turn into commercial if there any improvement. We say marginal due to moderate reserve located remote in offshore, waxy fluid that need process and complex facility. An objective. First is to obtain integrated alternative configuration for development. Second, to obtain optimum cash flow from alternative selected. And the third is implement risk management to minimize the risk and its effect. Methodology is sequence of steps that will be carried out for development. We have 5 steps here. First is determine concept. Second, set of configuration. Third, technical study. Fourth is economic study. And the 5 is optimization. Determine concept. We have 3 basic concepts here. First is reservoir draining. At this session, we select only the secondary. Second is wellhead control. We have 2 options, SubSea and Topsite. And the last is facility for processing, production, storage, and offloading. Consists of 3 options, CPP, FSO, and FPSO. Set of integration. Configuration. Standalone here means that we're still using diesel as a basis. We have 5 options of configuration that is come from the reservoir, wellhead, and facility combination. First option is secondary, subsea, and Lease FSO. Second option is secondary, subsea, CPP, and Lease FSO. Third option is secondary, topside, and Lease FSO. Fourth option is secondary, topside, CPP, and Lease FSO. And the last option is secondary, topside, and ownership FSO. You can see illustration here. Here are the details for every option. For your reference, this is the option 1, option 2, option 3, option 4, and the last option is option 5. Now we go to results. Production profile optimization. Waxy oil has a characteristic, a very heavy density. Without advanced technology, the well will not last long. To be able to extend the well life and to maintain a constant production rate, downhole pressure must be maintained. For that reason, we supply compressor for gas lift and gas injection. We see in the green graph here, production at 10,000 barrel oil per day will be continue for about 1.5 years. After that, will decline up to end of life. Process flow diagram. You can see here we have three sections. First is gas field, consists of wellhead platform and one of production line. The second is oil field, consists of wellhead platform, one gas injection line with 5 production line optimized with a gas lift. And the facility at a FPSO, we have 3 phase separator to separate liquid become oil, gas, and water. Oil will be stored in the tank and the gas will be used for fuel gas and dehy and also decompress for gas injection and gas lift to oil field, while the water produced will be treated then overboard. Topsite wellhead control has high feasibility for operation, require lower investment and operating costs. Surface facility design based on fit for purpose philosophy abroad. Hazard analysis applied to examine process and design engineering related to potential failure of function and their consequences. Assessment based on existing protection and severity based on final consequences, with priority scale to determine whether unidentified hazard have sufficient attention. Simulation with production rate 10,000 barrel oil per day for 10 years operation will produce gross revenue at total 1,068 mm USD. The use of diesel will be costly. It could consume up to 140 mm for fuel and addition 2 mm to provide nitrogen bottle required for gas lift and gas injection. Utilization gas from failure will be the most economic solution. Additional capex 50 mm requires to build wellhead platform and laying subsea pipelines, but it could generate efficiency of OPEC 130 mm. You can see here economic indicator based on PSC cost recovery. Production rate, fuel, and oil price are predominant factors to forming the economic value. So the development must be encountered to be able to produce 10,000 barrel oil per day, utilize gas as fuel, and forecast out moderate oil price at 65 barrel oil per USD as a basis. Economic indicator based on calculation of 5 options. We can see here option 3 will provide the most attractive financial benefit. Government take at about 33%, contractor take 10%, IRR 12.8 and POT for 4.5 year. IRR higher than MAR. It means profitable. Total investment could be come back within 4.5 years and generated positive cash flow onward up to end of the life. Sensitivity of IRR. We see here basic parameter we use with plus minus 20% of a variance. CAPEX, blue graph, small CAPEX will generate bigger IRR. CAPEX is high contributor to IRR. Maximum addition is 15%. It will generate threshold where IRR is equal to MAR or 10%. OPEC, green color, is small. The OPEC generate big IRR. OPEC only can give a small contribution to IRR. And the yellow graph is oil price. Cheaper oil price will generate small IRR. Oil price is high contributor to IRR. Maximum decrease is about 12%. It will generate threshold where the IRR is equal to MAR or 10%. Sensitivity of net present value with basic parameters same as IRR. From the graph, we have a meaning CAPEX, the blue color, small CAPEX will generate big NPV. CAPEX is high contributor to NPV. Maximum addition is 15%. It will generate NPV at MAR or 0. No, green is for OPEC. Small OPEC will generate bigger NPV. OPEC only can give a small contributor to NPV. And the yellow graph is for oil price. Cheaper oil price will generate small NPV. Oil price is a high contributor to NPV. Maximal decrease is about 12%. It will generate NPV at discount factor or MAR equal to 0. Share portion of the revenue. Option 3 will the most attractive financial benefit for contractor and government. Cost recovery at about 609 mm or 57%. Government take 349 mm or 33%, and contractor take 110 or 10 mm. Detail you can see here on the graph. Tag profile graph. Red and pink is a yearly annual revenue, while blue, dark blue, and light blue is accumulate revenue. We can see here for after 4 years, the contractor will get a positive revenue until end of the life. For all concept we have explained before, the development concept will be option 3, which is consists of a secondary well drainage, topsite wellhead platform, and lease FPSO. Production rate at 10,000 barrels per day, utilize gas as gas injection, gas lift, makeup, and source of fuel. Now we go to conclusion. Development of marginal waxy oil shale required gradual step to overhaul an existing conventional standard by adopting new fit-for-purpose philosophy. Implementation of philosophy, technical study, and risk management are very important to select an option of each parameter to be used to assemble as a set of integrated solution. Economic study utilizes it to get a big picture of economic indicator as a basic lead to select an option which is embedded with standard technical performance, optimum cash flow, and could give most attractive business value. Risk management through HAZOP is effective to identify any possibilities of failure, its severity, and to select additional control required. So the most optimal solution to develop offshore marginal waxy oil shale X is option 3, integrated with gas field Y. Suggestion: revenue, CAPEX, and OPEX are internal parameters which can be controlled by contractor and have big contribution to economic indicator. For such reason, development shall be directed to fulfill those aims through below steps. 1. Maximize revenue by optimize and maintain production level. 2. Minimize budget spending. 3. optimizing other opportunities. This our reference used for this conference. Thank you. That's all from me. If you have any question, you can drop down to my email shown here. Thank you.